Hi, welcome to the mathematics in my channel. Today we are going to solve another interesting integral. The question is, show that 0 to infinity x to the phi minus 1 over e to the x minus 1 dx is equal to gamma of phi times zeta of phi. Okay, how to begin? In this video, however, I am going to begin using definition of gamma function. So we know gamma of x is equal to integral from 0 to infinity t to the x minus 1 times e to the minus t dt. Now I am going to use a substitution. So if we take t is equal to k times u, now differentiate, so dt is equal to k times du. Now here limit 0 to infinity. Now after substitution also limit is 0 to infinity, so we can write 0 to infinity. Now t is equal to k times u, so k times u to the x minus 1 times here e to the minus t. So we know t is equal to k times u, so minus k times u times dt. dt is equal to k times du. Then here 0 to infinity. Now here we have k to the x minus 1 power and here k to the 1 power. So we know k to the x minus 1 times k to the 1, so k to the x power, here u to the x minus 1 power times here e to the, we can write here this is equal to e to the minus u to the k power here du. Well, now we are integrating with respect to du, so k to the x is a constant, so we can write outside of the integral sign, so k to the x 0 to infinity u to the x minus 1 times e to the minus u to the k power du. Well, now here we know we have gamma of x. Now I am going to take k to the x for this place, so we can write 1 upon k to the x is equal to 0 to infinity u to the x minus 1 e to the minus u to the k power du. Okay, then now we can take infinite sum both side because I'm going to take zeta function. So now if we take infinite sum, so here k is equal 1 to infinity gamma of x times 1 upon k to the x is equal to infinite sum k is equal 1 to infinity here 0 to infinity u to the x minus 1 times e to the minus u to the k power du. Well, now we can write here infinite sum, we can write gamma of x is equal to, sorry, gamma of x times here multiplication times sum of k is equal 1 to infinity 1 over k to the x is equal to, here we can write integral from 0 to infinity u to the x minus 1, then infinite sum k is equal 1 to infinity e to the minus u to the k power du. Okay, then here this is familiar with us, because we know this is equal to zeta of x. So we can write gamma of x times zeta of x is equal to integral from 0 to infinity u to the x minus 1. And now here this part, we know this is infinite geometric series, so we know sum of infinite geometric series, we take s infinity a over 1 minus r, so we can write here a is equal to when k is equal 1 to e to the minus u, so e to the minus u over 1 minus r is equal to also e to the minus u here du, then 0 to infinity here u to the x minus 1. Now I am going to multiply by e to the u in the numerator and denominator. So if we multiply by e to the u, here e to the minus u times e to the u get cancelled, so 1 over here we multiplied by e to the u, so here 1 times e to the u minus e to the minus u times e to the u get cancelled, so 1 here du. Now gamma of x, here zeta of x is equal to 0 to infinity u to the x minus 1 over e to the minus u minus 1 du. Well, now instead of x we can substitute p, so we can write gamma of p times zeta of p is equal to 0 to infinity u to the p minus 1 over e to the u minus 1 du. Now in our question we have dx, so now we can change the variable, so we can write gamma of p times zeta of p is equal to 0 to infinity here x to the p minus 1 over e to the x minus 1 dx. Okay, we are done. If you like this video, please subscribe this channel. Thank you for watching.